Good morning, everyone. Welcome to this session. Decide between in-process and inter-process communication at deploy time. If you've been this morning to the introduction part, you probably already know what it's going to be about. If not, you'll get a very good idea by the end of these two slots. Before I start, I want to express my gratitude for the organizers for having me here and for organizing this great event. I hope you enjoy it. And I'll also spend a few minutes to introduce myself. My name is Florin Coros. I'm coming from Cluj. That's for the ones which are not Romanians, it's in Transylvania, somewhere in the middle of Transylvania. I like to play Go, and I like to listen to rock music and to tweet. I work at two organizations which I've co-founded, iQuarc and atInifiniSwiss. iQuarc is a consultancy. We also do some training. And atInifiniSwiss is a software development services provider where we have a very strong focus on technical quality and doing things right with a small but very experienced team of developers. This is what we are going to talk a lot in these two sessions, the communication between a service and a client. And we are going to look a lot on this arrow. We are going to play with the way that arrow gets materialized into at the runtime. At a very simple form, this could be just the classes. The service implements an interface, the client calls the service. Now, if we put these two in the same process, they will communicate as usual, meaning the service will simply call the functions of the client will simply call the functions of the service. What we will do in this session is to see a technique through which, if we just copy the service, the assembly where the service gets implemented, we just copy it into another folder, and we load these two things in different processes without changing the code and without changing configuration files and so on. They will communicate through a REST API endpoint, the same two classes without any changes to the code. And maybe the first question would be, why is that important, or where is that important? And I would be curious, how many of you have seen a diagram similar with this one? Not this diagram, because no one has implemented anything based on this, I've just drawn it. But a diagram with many boxes, somewhere on the bottom, a few cylinders, which are the databases, then probably fewer boxes here on top. Those would be the user interface applications. And somewhere in the middle, a cylinder, which we call message bus or enterprise service bus or stuff like that. Now, this is a typical picture of a highly distributed system. And the reason we are building these architectures usually come because we want to implement these requirements. These are just some of them, and maybe the scalability would be the requirement which in most of the cases triggers something like this, just split things up. And in some systems, especially if you think, for instance, to an insurance systems, you get the need to be able to scale in a different way the backend from the front end, because in insurance, there are many processes which happen on the backend, and not that many people check their policies, how much money did they save for the pension daily. So you don't need that much scaling on the front end, but you need a lot of scaling on the back end. So splitting things up gets a good support for implementing these kind of quality requirements or quality attributes or non-functional requirements. Same names for more or less the same thing. Another important set of quality requirements would be this category, where maintainability maybe is the most prominent from them. Like, if you have a modular system, then it's going to be easier to develop it, test it, maintain it, operate it, rather than having one big thing. And because of this, we started to split things up. And also testability. If you have something like this, you could test in total isolation, partial isolation. You could imagine many testing strategies. Another important thing would be migration. For instance, for a bank or for an insurance company, you can't really say, we are closing the bank for 2 years because we are migrating from Delphi to C#. that's not really going to happen. So you need to be able to have an architecture that allows you to have a continuous migration or continuous modernization of your system. So you take out maybe 2 or 3 subsystems, migrate them to a technology which is more suitable, and have those working in parallel with the old ones. So this would be the reasons why would we more or less go towards these complicated architectures rather than one big thing. This was like the client service architecture we had a few years ago, and then we split it a bit and we had 3-tier architecture like front end, back end, and database. So these are more or less monoliths. And I was a few years ago at a client. They are a bank which are doing only trading, so trading bank, selling shares and stuff like that. And then spend years for migrating from something like this is what they had at a certain point, to a distributed architecture like this. And their main reason was maintainability, the ability to make releases at least once a year. So when they were big, they were having just one thing, it was very difficult for them to make a release. They were very waterfallish. And they spent like a few years to migrate, to split things up, rewrite many things, and get towards a modular system. They were really, really happy when I met them because they were able to do a release every year. And they were having plans to have automated testing and to have releases maybe each month, which they said, okay, if we can release each month, then it means we can release more or less when we want. The biggest problem was that they split things up, but to make a login, for the user came over here on the user interface and made a login, they had in the backend like 25 calls between their systems. So they had like 25 hops just for the login request. And that somehow was bad for performance. They were having like 2 seconds per login. They could have done some small optimization, but still there were too many hops. And that was not only for the login, there was also for placing an order. And in trading, if you want to buy and sell shares, you really cannot afford these performance problems because you have more or less respected the industry standards and you split things up. So they were a bit, not a bit concerned about what to do next. I mean, one strategy, as I made the dependency between the order service, this would be the service that allows us to buy or sell shares. So I could place a sell order or a buy order, and to do that, I also need a quotation to see if I could actually buy the shares at the price that I am willing to pay, or if I could sell at the price that I am willing to sell. So I have 3 services, and they all depend on the quotation service. And what we will try to get to is to a point where we can deploy these 3 services in 3 processes. We will develop a small console application which will host them and will expose them as REST APIs. Have them communicate at first as an inter-process because we are using Web API to implement this, so it's just going to be REST calls through HTTP. And then we'll imagine that the order service has performance problems because of this communication with a quotation, and we are going to copy the quotation into the binary folder of the order service, and when someone else will make a call to the order service, this will not trigger an inter-process communication, but will trigger an in-process communication here. We might keep the quotation service hosted by itself for the portfolio service or for other clients which are maybe in our ecosystem. Okay, so this would be pretty much the plan. And now I'll switch to Visual Studio. And maybe we'll come back during the demo to these pictures so we can rely a bit where we are. I'm taking a bottom-up approach, meaning that we are starting almost from zero. However, we have limited time, so I have all the code already written in Git. It's available on GitHub. But we will go step by step from an almost empty solution towards this picture. If you can't hear me because I'm sitting down, just tell me so I can speak a bit louder, or maybe even try to code from standing. Okay. So going to Visual Studio, here we are. So we have an almost empty solution over here. I only put here some structure for my solution. So I have an infrastructure folder. There's going to be the place where we put everything which doesn't have anything in connection with implementing the business logic. So that's going to be the proxies we are going to use. There's going to be the plumbing code. Then we have the modules folder, where it's going to be the business logic. And I already created folders for the portfolio module, for the quotation module, and for the sales module. And then I have contracts, and then I have some console applications, which will be the executables. All my projects, except the console ones, are just libraries. And at this point, they are pretty much empty projects. The main techniques that we are going to use to achieve this are these. So basically, the way to implement all this relies on three main design ideas. The first is we are only going to depend on contracts. We don't allow our implementations to depend directly on another implementation. So only contracts, and those contracts should be described in code through abstract types. In C#, that would mean interfaces and DTOs. We won't have any logic into the contracts assembly which you've seen on Visual Studio. And that's going to be more or less like the common language between our subsystems. And we want that as contracts assembly to be available everywhere, but the implementation is not. The next important design idea is that we are going to use proxies to forward the call from a contract to the contract implementation. And this is one of the important things, one of the keys to implementing this technique, because depending on which proxy we are going to use, that's how the communication will be done. And third is type discovery. Type discovery, this is important because we want to find out when the application starts, when an executable starts, what has been deployed in there. So in C# and .NET, this is implemented with reflection. In our case, in our demo, we are going to use a library we have written on GitHub, so we don't write the reflection by hand now. And we are going to look a bit through it. In other languages, you could just use any other method or technology to read metadata of your code. So type discovery, proxies, and contracts. Now switching back to the code. Oops, I need to close this in order to switch the resolution. So switching back, we have into the contracts, as I said, we only have contracts, interfaces, and DTOs. So for instance, if you look to the quotation, there is the iQuotation service, which has these three functions, like get quotations by different parameters. And besides this interface, which would represent, let's say, the operation contract, if you think to WCF terminology, we also have the parameters, the input and the output parameters of our methods, which would be the data contracts. So the quotation only has getters and setters, and no logic in here, no validations, nothing else. Plus, in a real system, not a demo app, we also might have here the fault contracts, which we could express through exceptions, which should be serialized. Now, one thing to notice here is that these functions do not use abstract types, meaning I don't have there an enumerable of quotation. I prefer to use an array because I prefer to have data types which are easily to be serialized in as many as possible formats. So for instance, an enumerable or an list is hard to be serialized with certain serializers. So to SOAP, it's somehow trickier. And if I do this from the beginning, I also leave the door opened to change the communication technology. Now we are going to use this with REST API because it's maybe easier for this demo. But in a real scenario, real application scenario, probably in .NET I would use here WCF because it's a technology which is closer to remote procedure call pattern rather than this one, which is stateful mainly, and it's not that appropriate for communicating inside the system, inside some very well-defined boundaries. Okay, so this would be the quotation from the contracts, and over here I have the implementations of these services. So for instance, if I look to the quotation and I look I go to its implementation, I have a quotation service, I hard-coded here some quotations, and my functions only filter those. Now if I'm going to the portfolio, again I'm going to the portfolio service, and this is just a simple function, get portfolio, it returns a value. If I go to its implementation, then I see that the portfolio class does not depend directly on the quotation class, so I don't allow a dependency towards the implementation, but it depends on the contract. And the contract, this iQuotation service, is received through the constructor. So it means that I will need to use dependency injection, so some other framework which knows to inject in there the implementation that I need. Here in the get portfolio function, basically what I do is, okay, I get all the securities that I own, Apple and Microsoft, of course, and then I'm using the quotation service to get the quotations for this security at this moment, and then I just sum the bid price and I get the value. What's important for our demo here is just to remember that the get portfolio value function needs to call a function from the quotation service, so the dependency among these services. Okay, now another important rule, which I mentioned, but we should check it and enforce it regularly, is how we allow references among our assemblies. And I generated here the dependency diagram. You can see here that I don't have any references. I lost my pointer, but anyhow. We don't have any references among the modules. Portfolio services does not have any reference to the quotation service, and the other way around. And this is something that we should check frequently. If we would allow direct dependencies, it would mean we could not deploy these on different processes. They all depend on the contracts because they either implement a contract in there or they either consume a contract in there. Also for the host processes, so I have a console UI, which mainly will be the user interface of our demo app in a console, and the console host. So these, again, do not depend on the implementations themselves, because I want to have some generic hosts, meaning that at least the console host to be able to host the services from any module, and not a particular one. Okay, now let me think if I forgot something important. I don't think so. Let's do some work into the console UI. So mainly here, the first step that I want to check is that if I call the simplest function I have in my demo, so that's the portfolio service get value, if I call that one, it works. At this point, I only have some DLL, some libraries, simple class libraries with simple implementations. They are not actually linked one to the other because I don't have the references, but I would want into the console app just as a first test to see that things somehow work together. And here the console app is rather small at this point, so I have some blah blah for welcome, some blah blah for goodbye, and I have a display portfolio value, which goes like this. I get a reference to iPortfolio service. I don't write here portfolio service because this would require me to make a reference to the portfolio implementation, and I don't want to do that. So I'm using a service locator to gather real implementation, and I call the value. At this point, if I call it, if I run this in Visual Studio, I get an error saying that the service provider wasn't set up. So I didn't do any setup to the dependency injection yet, so that's why this crashes. And now is the moment to somehow configure my container. And to do that, to have something that glues up all these things, we are going to use in the demo a small library which we have written. You can find it on GitHub. It's open source. So github.com/iQuarc, and you go into the app-boot repository. And mainly this is, as we write here into the README file, it's a generic bootstrapper for any .NET application. And it does two important things. One has to do with dependency injection. It configures the dependency injection container. And the other one initializes a composite application. For our demo, we are going to use the first part to implement the type discovery. That's one of the key design ideas that we need to implement. So the first one is for having the type discovery done, and the second one is to have the modularity, some support for the modularity. We are having 3 modules, and we would want some logging to see what module has been loaded by a certain host. Now, the app-boot, what it does is only using reflection. When the application starts, it gets a set of assemblies, it scans those, and makes the configuration of the dependency injection container based on some conventions. The library doesn't depend on a specific container, dependency injection container, so you could write adapters for any one you want. So if we come back to our demo, what we need to do is come and install it. I already should have it installed for this stage. So I have the iQuarc app boot NuGet package, and also iQuarc app boot.unity. Mainly this one is the adapter to Unity dependency injection container. So now if I want to use it, I would need to come here into my application and say, okay, bootstrapper. This is an object defined by the iQuarc app boot library. It's just the entry point, mainly. You create an instance of this guy. You say, okay, new bootstrapper. This one will require some assemblies. And then I'll just get those. This would be all the assemblies which compose my application. So I'll just say here, get application assemblies. Application assemblies. And okay, I'll get those, and then then I could just say over here, once I have the bootstrapper built in, I could say bootstrapper run. Now, this is the function which will do that scanning that I was telling you about. And to do the configuration of the container, we need to say to the bootstrapper, okay, you should use Unity. This extension method, helper method, comes from appboot.unity package. If you would use something else, then you would need to write this one by yourself. And another thing, which we will see later on why this is very important, is that we need to specify here the convention we want the appboot to use in order to make the registration into the dependency injection container. Basically, to configure any dependency injection container, the simplest way would be to have an interface and its implementation. And we are saying here that we want to use the service registration behavior, meaning that we want to say, for instance, for our portfolio service, we want to come here and say, okay, this class, the portfolio service, is an service, meaning an implementation for the iPortfolio service contract. Now, when the types are being scanned, the appboot will look after that attribute because we've configured that behavior, and will make the registration into the container. And now, if we run this thing, I will just make a step forward in Git. So I also get that function. So basically what I did with stepping forward, I also implemented these get application assemblies. I could scan all the assemblies in my output folder, but not to waste time by looking into Microsoft assemblies and so on. I have here some filters which say scan the contracts, the portfolio, the quotations, and the sales. So basically I'm scanning everything that is deployed, and I'm just going to use what I find in there. And now if I go into my function, the display portfolio value function, this should work, meaning that if I put a breakpoint in here and I can hit F5, okay, the service which I received here is a portfolio service as the implementation. If I go into the execution of this function, it gets a quotation service, so it will communicate with the quotation implementation, and I will get a sum of my portfolio. So I got this value of $27.3. This would be the value of my hard-coded shares at Apple and Microsoft. And I also added here into the console a small call towards the ordering service, and it asks me, okay, what's the price limit you want to use for buying stuff? So this one made a call, the console made a call, so the console application made a call towards the ordering service over here, and the place by limit, if I go to this guy implementation, made a call towards the quotation service, and if it found a quotation which is with a price lower than what I'm willing to pay, the order has been placed. And after that, my console application also makes a call towards the same ordering service to see which are the orders which I've placed. So I write here into the console the result. So basically at this point, with our demo, we have somehow implemented this, meaning we have a fat user interface, a fat process for the entire user interface. It's like you would host the entire distributed system on the user machine. You might do this for testing purposes. Now the next steps after the break are going to be, first, implement the host so we are able to expose all of these services as endpoints, REST API endpoints. Then implement the possibility that one of these guys can call the other through REST, and then glue the things up together and make the final demo that is in this picture. So let's have a break. I think it's until 11:20, and then we'll continue with the demo. Grab a coffee. It's going to be much more interesting. Yes, the entire source code, you can find it. So the entire source code, you can find it on github.com. You again go to iQuarc, you go to the code design training repository, and you go into the inter-process communication trading. And here is the entire sample, plus you'll also see here into the notes a script which shows you how to build this stuff from an empty solution to the end. I started from step 5 or so.
And the presentation?
Sorry, self-host, API self-host. So this package, Microsoft ASP.NET Web API Web Host. Install this, and basically you'll be able to listen on a port and implement an REST API. Another thing that we are going to use is the upboot.web API, and you'll see in a minute why. This is another extension we have made to the upboot core library. The upboot by itself, it's independent of the dependency injection. It doesn't do dependency injection by itself. It just wraps over a container. And it could be hosted or used in any .NET process. And this is an extension to use it with an web API. So I won't install this, but I'll make a step forward in my Git history for having these packages installed. So we are going to this step. And now if I'm looking to the console host main function, basically what I did is after I installed that package, I could use this web app class called start function and listen to a base address which I read from a configuration file. And I only have here a loop which waits until someone presses escape to close the server. So when the escape is pressed, the using statement will call dispose on my web app, and that's pretty much done. Pretty much it. Now if I go to the startup, this is the configuration class the web API will use. And by the way, this is code which you will find if you Google after how to self-host and web API in .NET. This is standard configuration, but what we still need to do for our console host is to do the same app boot configuration as we did for the console UI. So I added this line here, which if I go into this static function, it does the same thing as we did for the UI, for the console UI. So basically I get the assemblies on the same rules, all the DLLs, and the ones which start with the contracts, infra, portfolio, and so on. I configure the bootstrapper to use Unity, and I also want to use the same convention, meaning that look after the service attribute for implementations. So now if in my console host output binary folder, I get types which are decorated with a service, they will be registered into this guy dependency injection container. And the next thing that I need to do is write a controller, a web API controller, so I can answer to web requests. So let's look to the portfolio controller. I added here the controllers folder. I could have not, but I prefer just to order them a bit. And the controller does nothing else than just forward the REST call towards my service. So for if someone will call get value, then I need to call the portfolio service and forward the call to it. What's important here is to have a mechanism which will make sure that when the web API framework instantiates the controller, it will use the same dependency injection that app boot configured. Because I want here to be injected the portfolio service implementation, the one which was found actually on the deployment folder. And to do that, if I go back to my into the console host program, main function over here, into the startup class, so here where the configuration is done. Basically what is done here, I create the bootstrapper, maybe it was clear to do it like this. So bootstrapper run, this returns the bootstrapper which was already executed, and then I say configure with a web API. So basically this code, basically this one makes the link between the web API framework and the container which was configured by the app boot. And what it does, if we go to the implementation of this, I will decompile here the code even if it's available on GitHub. It says to the dependency resolver from the web API that one is an adapter over the service locator which comes from the app boot. So basically now if I will run my host, each time the web API will build a new instance of my orders controller, for example, I will receive the implementation of the order service. So let's do that. Just rebuild everything. Okay, and I'm running the host. So my server runs at localhost now 9000. I also implemented, when I did a step forward in Git, I also implemented some logging, meaning that now I log the modules which were loaded, and this is done by just trying to find into the binary folder the DLLs for my sales services, so this one, quotation services, and portfolio services. And in each of these DLLs contain an implementation for the iModule interface, which is defined into the app boot. So if I go into let's look into one of these guys. So I go to the portfolio, for instance, and over here I have a portfolio module, and this implements an iModule, which is defined by the application boot. And this interface only requires you to implement the initialize function. And in the initialize function, this one will be called on the bootstrapper .run. So you basically have the occasion to run some code when the application starts. And what I did, I used a container. This is basically a list into the implementation where all my modules, which if they are found, they just say register module with a string. And then into the console, if I go to the console of the host, Solution Explorer, console host. So over here, I get the container back, and I just write this on the console. So now, if looking on the console host, it says that, okay, I found the portfolio, the quotations, and the sales, and I'm listening to this port. And now if I go into Postman, I can make calls to this guy. So for instance, let's make a call to the portfolio, that being the simplest. Second. So portfolio controller get value. This is just localhost.9000, API portfolio get value, and some parameters. So if I run this, I get the answer back, 27.3. So what happened behind is the following. If I'm coming here and I just put a breakpoint into my controller, so I go to portfolio controller and I'll put a breakpoint here so we can actually see the execution of this. So I make the request, I get into the controller. I already have here injected the portfolio service. So the implementation of this guy is the real implementation, the portfolio service class. I go into the execution of this one, and just going further, get the securities which I have, which are hard-coded, and I get here to call the quotation service. The quotation service is again injected through dependency injection, and is the real implementation. So I have a communication between the portfolio and quotation, but this is in process, and it's just simple dependency injection, just function calls. And that's why if I continue this, I get the answer of, so in Postman I got the answer, which is a sum, which came from the quotation. I did a filter, a web API filter, which logs into the console all my requests. So through the demo, we can actually see if calls come to our server. So now I've seen that I had 2 calls to this endpoint, portfolio get value. Now, of course, this works if I also try to place an order. So place a cell limit order, I make the call, I got here on the server, someone made a call. Now, at this point, we could say we have a deployment, or we could do deployments that are similar with, let's see, with this picture. So I have a host. It can host one or all the services. We'll look to that in a minute. And it publishes as REST endpoints those contracts, so other processes could call them. But in between them, they will only use in-process communication. So this is where we are at this point. Now the console host, if I stop it now, and I go into it's been debugged. So this is been debugged for my entire solution. And I come here and I will just, let's say, delete the portfolio services.dll and run again the host. Now I only have now loaded the quotations module and the sales module. And now if someone, for instance, would make a call to the portfolio, which is no longer there, it will get an error. And in fact, over here the error is not that it's just an internal server error. That's the message that I get. Sorry. So, okay, so it's an internal server error. And the error message is not that explicit at this point. I could do some work into the error handling and saying something like, okay, this service is not available at this address. Basically what happens in our code is that when this call comes in into the web API, it tries to build the instance for the controller, for the portfolio controller. That one cannot be built because the dependency injection doesn't have something for portfolio controller. It doesn't find an implementation in there. So that's why it crashes. Now, if we want to get closer to our goal, it would mean that if certain service or certain module is not deployed there, we should use a proxy to forward this call to another place, to another process where that service is being hosted. So the next step would be to implement some proxies and make sure through our deployment strategy that the proxies are always going to be available everywhere. And that's how we are going to make that switch. So if the real implementation is available, I'm going to use that. If not, I'm going to use a proxy, and the proxy will forward the call to another server where that service should be available. But at this stage, I have this, let's say, generic host. It can host anything. And now if I close it, and for instance, let's say I'm deleting the quotation, so the service on which the orders depend, and also the portfolio. For instance, if now I will try to place a sell order, I will also get a crash. So let's go and say place order. And again, I'm getting a crash because for the same reason I couldn't find the order. The order service was found, but it had a dependency on the quotation, and the quotation wasn't there. So again, either forward the call for the quotation, so have an inter-process communication, or otherwise it should be deployed. Okay, now let's see how those proxies should look like. So basically, we need to write now some code which makes the calls on the REST API. So far, we only made the calls through Postman. Okay, so coming back to Visual Studio. Let's see the time. Coming back to Visual Studio, I have to do some work here into the infrastructure. I said that the infrastructure is going to be the place where we put the plumbing code. And basically what I'll do is create here a simple class library where we are going to write those proxies. Again, I'm not going to type the code, but just moving a bit forward. So this is the proxies class library, and let's look into the portfolio. Now the portfolio service proxy class implements the same contract, the same interface, a portfolio service. Only that it doesn't do the logic by itself, but it forwards the call through to a REST endpoint. So I'm using here an HTTP client. I get this built from an helper, which basically what it does, it sets up the address, and the address is being read from a configuration file. So I have a convention which says in the configuration file I need to have the name of the contract, so iPortfolio service in our example, _address. This is the key of the setting, and I should have there the address where I find this service. So this helper just sets up my HTTP client, and then once I have the HTTP client, I can say get on it. I get the result. If the status code is successful, then I just return the value. If not, I throw an error. So basically, this is just an implementation of the portfolio service, which forwards the call to another process. And as you can see here, I have decorated also with a service, because I wanted to see. I want to see if this is used and if this works, if the code that I written here makes sense. So now, if I would go back to my console app, if I build everything here, I configured my output folders for all of my projects to go in the same folder. So that's something that if you use this approach, something that you should do maybe from the beginning, meaning that each time you create a new project in here, go to the properties. Okay, now it's building up, and it cannot do that because this is still running. So rebuild. So you should configure somehow or make sure that for your debugging environment, everything gets built in the same folder. So I made here, I said, okay, the output path when we build this is at a higher level. And this is just a helper, so everything, all the DLLs go in the same place. You could use some post-build events or other means. For the portfolio, first was found a proxy, then the real implementation was found, and the real implementation did an override. For the quotation was the other way around. So now if I continue this, because I don't have a server listening, I might get an error. And yes, I get an error that it couldn't reach that REST endpoint. But I could run my console host because I also have that. So I'll go here at the same level with the debug, make here folder deploy, copy everything in here, and fire up the host. So now I have a server listening, and this one listens for at the same port for everything, for portfolio, quotation, and sales. And now if I go back to Visual Studio and run the UI, so the console UI. So let's see now. The implementation of these guys is the real implementation. So if I look which calls were made to the server, I have something like this. I didn't have any calls for the portfolio, but I did have a call for the quotation get by security. And this call was made by the portfolio implementation, by the portfolio service implementation. So, and it made a call to the quotation, an inter-process call, and I got back the answer. Now, my console application wants to make a direct call towards the quotation. So it asks me a stock exchange code. So I say, okay, give me all the quotations from New York Stock Exchange. And again, I've received a call on the server. So because if you remembered for the quotation, somehow the console UI loaded up the proxies. That's why I'm getting calls into the server. And now if I make a call towards my sales order, so it asks me, okay, give me a value, a maximum value for which you want to buy stuff. And again, I had calls towards the orders. So here, the console application got the proxy. It made an inter-process call towards the orders, but the orders didn't make an inter-process call for the quotation because on the host, I have everything loaded up in the same process. So once I reach the host in this point where we are with the demo, everything on the host is in process. Over here, I didn't put yet a scanning for the proxies, that's why. So now if I want to put some order into this, meaning make sure that always the UI will call services, imagining like the UI will be a dummy client, I could easily go there. So I'll just close this. Go here and say, okay, into the bin folder, I'm going to delete everything but the proxy. So I'm going to delete these services. I will start the host, and I will start the console UI. Now, if I look to the server, I already got a call for the portfolio get value because that was the first thing the console UI did, made a call for the portfolio, and now calls towards the quotation because quotation was the communication with the portfolio and the quotation was on the server in the same process. Now, if I make a call from the UI towards the quotation to get all the quotation from New York Stock Exchange, I get only one call on the server, and that's all. And now if I'm trying to place an order, so I input here 11.6, I hit this, and I got a call. I get a call here for place the buy limit order, so this one. And also the console made a call for give me all the orders which have been placed, so it displays them over here on the console. So now at this point, what I did, just by deleting those implementations from the UI, I have an deployment. So let's see if I have the picture. Something like this. Sorry, not yet. Something. I don't have that picture prepared, I think. Yeah, something like this, but without these DLRs in place. So the console UI is dummy, and it always calls the server, and always this communicates on the server in process. If I really want to get to this deployment and also have the implementations over here and make sure that the console UI will never call this guy, I need to go into my output folder, put back the implementations, the real implementations. So I'm looking for the DLLs only. And let's copy the portfolio services, quotation services, sales services. Copy. Oh, sorry, the DLLs. That's right. Portfolio services, okay, these guys. Overwrite. I also overwritten the PDBs. Okay, and delete the proxy. And close the application so I can actually delete them. Now close the proxy, delete the proxy. Start the host so someone listens. Okay, on the host I still have the proxies. I still have the implementations. And if I start the UI, this should send no calls towards my server. So no call has came for the portfolio value. If I call the quotations to give all the quotations from New York Stock Exchange, nothing came to the server. And if I place an order again, nothing came to the server. So I was exactly like in Dick's picture. Everything was deployed everywhere, but because this one didn't have the proxies and had all the implementations in here, it only made in-process calls. Okay. Now, the next step would be make some prioritization between the proxy implementation and the real implementation. And to do that, we should do some configurations into the application boot, because that's the one which configures the container. So I'm going now into my console UI over here, and I'll go into the place where the console UI gets configured. And what I want to say basically is here, first use the service attribute. Use the service attribute, but before that, use something similar with the service attribute, which is called service proxy attribute. I don't have this yet, but I would want to have something like this. And also I would want here on the where I have my proxy implementation, I would like to be able to say, okay, this is not an actual implementation, but this is a proxy. So I would like to have this in place. And to do that, we need to write them. And I just step forward with this, so we can have a look on how they look. So basically what we have now is, here into the infrastructure folder, I have application boot extension class library, which contains those things which I was missing. The service proxy attribute. This is exactly how the service attribute is implemented into the app-boot library on GitHub. So I have the service proxy attribute, and I have this registration behavior, which needs to, the interface, the registration behavior is declared by the application boot, and it asks us to implement this get services function, which says, okay, this is the type that I found while scanning. What should I register into the container from it? And I could say nothing, so I don't return anything into this enumerable, or I would say, okay, do these registrations. And for the service proxy, I would want to say, okay, put into the container that the type which I get from the attribute, so meaning the portfolio service or the contract in our case, is the interface, and the implementation of that interface is the type which was decorated by this attribute. So now if I rebuild, and close first the consoles. Okay. Now I will also overwrite. So I copy from the bin debug everything into the copy I made for the bin deploy, and I overwrite everything there. I run the host, and I also run the console. Here, the console UI. So now, if we look into the console UI, everything is available. So the proxies are deployed, the services are deployed, everything. But because we have this priority in place, proxies won't be used. Always the real implementation. So if I run it, I just make the calls because I'm a bit late with the time. So if we look now into here, no calls have been made. I'll keep the server running. I'll delete the implementations from the console UI. I run the console UI, and now I should see calls to the server for each service the UI needs. Okay. Oops. Oh, I didn't enter a correct number for the limit price, but anyhow, I got the calls here. And now there is only one step we still need to do in order to get to the endpoint where we want it, meaning this picture. Host each service individually. And make sure that the portfolio service will use a proxy to call the quotation service if it doesn't find the implementation in there. And the thing that we need to do is to do on the console host the same configuration as we did for the UI. So we go here in the place where the app boot is being configured, and you say to this guy, okay, you should use first the service proxy registration behavior. This asks for a reference to the app boot X. And we should go here where the assemblies are being filtered and say, okay, you should also look into the proxies. Yeah. Now if I build this, it will make that deployment possible. But I will run it after I make another step forward, because in this step, let me see what's the number. In this step, I also have some batch files which are executed from the post-build event. And those batch files will make a deployment for each of my services. So, coming here, I'll just delete the bin folder, build everything. I had some copying being done. And now if I look into the bin, I have a deploy folder, and this one contains a host. All here were copied all the implementations and the proxy. And then I have a portfolio, and this one contains only the portfolio services and the proxies. One for the quotation, pretty much the same, and so on. And now I have here a batch file, which will execute all these. So basically this started the console host, and I have 3 instances of it, each of the instances hosting one module. So I have here the portfolio at 9001, I have the quotations at 9002, and I have the sales 9003. Let's order them a bit like this. So in the middle we have the console for the quotations, and the quotation is the one everyone needs. And now if I go into Postman and make some calls to these guys, so let's say place get value. If I get value, I'm having a call made to the portfolio get value, and this guy made a call to the quotations. Let's see the quotations over here. And I know that this call, the get by securities, came from the portfolio because I log here the remote. So the remote, the guy who made the call was the proxies with this ID, F something. And over here into the portfolio, the call came from Postman. And the same if I'm going to place an order. I have an inter-process communication between this process, which hosts the order service. So the call came from Postman, and this guy made a call to the quotation. Now if I'm just closing the sales, I'm going into the folders and I will copy. I'll just have the same thing on the right side as well. So I'm opening the sales deployment folder. I'm going into the quotation. I'm going to copy the quotation services DLL over the sales deployment and restart the sales. Console host for the sales. So now the console host at 9003 hosts the quotations and the sales. And now if I make a call from Postman to the place sales limit order, this one got the call, place sale limit order, but on the quotation, which is this one, I didn't receive any other calls. So I have 2 calls from the previous run, which were from F something, and this guy, which hosts the sales, has a proxy which starts with 0 something. So I had this scenario. First, all were hosted individually, then I just copied the quotations over here, and they were now using an inter-process communication. Okay, I was a bit over time, sorry about that. I will still take 2 questions if you have any. Yes?
All the projects have dependencies on contracts.
Yes.
How do you manage the changes in contracts?
So the question was that because all the projects need to have dependency on the contracts, how do I manage the changes over there? Well, basically, when contracts change, I will need to update all the contracts. So it's just called I redeploy all the services. All my assemblies have a strong reference towards the contract. So if I build, for instance, the sales, the contracts will also get built. Now, if we are thinking about conflicts and stuff like that, that's as it happens for any code. Nothing special. Other questions? Yes.
First, in addition to the last answer, would be that if you put the contracts in separate assemblies, the impact is lower.
Yes.
Basically, you have less trouble. The other thing on the get assemblies method, the one that searches for assemblies, I've seen a filter for the contracts. Why do you need that? Contracts assembly.
Yeah, you're right. I don't think that's actually needed.
Okay.
I don't think that's actually needed.
This is referenced statically.
Yes.
Okay.
Well, the filter over here just says, okay, these are the assemblies that you should scan for dependency injection registration. And it looks over that service attribute. The contracts do not have the service attributes in there. So actually, if you would look to the references, by the way, the entire code is on GitHub. If you go on github.com/iQuarc/code-design-training/interprocess communication, there's where you find the entire code. And if you look now at the references, you'll see that the contracts doesn't have a reference towards the application boot. I think it's the only one. Okay, thank you very much. I will be available for more questions for the rest of the day. I'll also be at the open space, so just come and ask me more if you want.